So we're doing lesson 2, solving quadratics by factoring. Now guys, the difference between what we've done in the past and what we're doing now is instead of it equal to y, what is the equation equal to? 0, right? We're going to solve for it. So we're solving for x. This is algebra. This is like algebra you did in grade 9 and 10. The only difference is we now have a square in there. Okay. So you have to deal, there's a few steps, and I always try to do the steps, right? You always do the brackets first, don't you? Then you usually put in, what's the first letter, or it's usually an X in there, right? And then you look at the signs, and you look at the sign. If it's a positive, it means the signs are the same. If it's a negative, it means the signs are different, right? You know this. And then you look at the first sign, and that tells you what number you want to do. Now, the hard part is determining whether or not, or what these numbers are here, right? That's the hard part, is determining those numbers. It just takes practice. Right? So that's the basic factoring. Now, to solve it, all you do is you make this side equal to 0, or you make this side equal to 0. That's it. You either make the first one equal to 0, or you make the second one equal to 0. And you just solve for x. That's it. You're going to get 2 answers. Now, eventually, what's going to happen is you're going to get 2 answers, because that's the mathematical way of it, but some of those answers aren't going to make sense. And we'll get to those. Okay, so let's just do this. We'll go right into it by doing examples. Are they on the first page or the second page? Where are they? Where are they? Oh, I put them on the second page. Okay, here we go. So let's do the first one. So 2x squared minus 2x minus 12. There it is. What are we going to make it equal to? 0. Just make it equal to 0, because that's what we're going to solve for. Okay, how do we factor this? Okay, hang on. Before we put it into the brackets, you always got to look, and you always got to remember this from previous years. You always got to look for a 3-letter thing. You always got to look for GCF. You always got to look for the greatest common factor. No, it's not 2x. Look, it's not 2x. You can take a 2x out of there, you can take a 2x out of there, but you sure can't take a 2x out of the negative 12. What is the GCF in this case? 2. So we take out a 2. So then we have, we'll put our big bracket there. So 2x squared divided by 2x, or 2 is x squared. Negative 2x divided by 2 is negative x. Negative 12 divided by 2 is negative 6. Okay, so we've taken out our GCF. Now, that 2 in the front, will it have any effect on our equation? Because it's equal to 0. I mean, you could look at it this way. Could you divide the left side by 2 and the right side by 2? Yeah, what's 0 divided by 2? 0. So it really has no effect. You could if you wanted to, but leave it there because it'll help you keep organized. Okay, now let's factor this guy into 2 binomials. So again, I write down my brackets. Is it the same steps over and over again? It is. What times what gives us x squared? X and x. That sign there in front of the 6 is negative, so our signs are different. We want factors of 6. 1 and 6, 2 and 3. Those are the only factors of 6, so it has to be some combination of those numbers. But we want the difference to be 1. Wow, so is it 1 and 6? What's the difference between 1 and 6? 5 or negative 5, depending on how you subtract them. Is it 3 and 2? Yeah. 3 and 2. That gives our... Now, I'll put in 3 and 2. Now, we have to decide. We look here, and we see that, hey, that one's negative. So we want our answer to be negative. So the bigger of those 2 numbers has to be negative. So which one is it? The 3. So that has to be positive. Now, if you're unsure about that, could you FOIL it and check to see if you did it right? Yeah. The thing about this is you'll never get it wrong as long as you do the FOILing, because you can always check your answer. Now, to solve this, what do we do? There, so we do one. And sometimes what I'll do is I'll often do it this way. I'll put like a line here or a line here, just to show that I'm going to go, I'm going to go x minus 3 equals 0. There's one of them. And x plus 2 equals 0. There's the other one. Right? You'll often see me do that. It just keeps me organized as I go along. So what's x in this case? 3, and x is negative 2. Now, if you wanted to, could you check those answers? Take them, plug them back into the original, see if you get equal to 0, see if it works. That's a basic one. Okay? This is just factoring. That's all we're going to do for the next Less than 2, less than 3, less than 4. It's all factoring. We just get harder and harder. Sure, we're going to do that. Yo. Okay, but then you still have to factor it out. So you're talking about 2x like this, 2x, oops, and the other one is just x, and what are they? 4 and...
No, I'm saying that when we have to just make it equal to 0, don't we need to multiply that bracket with 2?
What difference does it make? If you do it by 2, it won't make any difference to the answer. Look, 2x minus 6 equals 0, right? So you have 2x minus 6 equals 0. So 2x equals 6, x still equals 3. It won't make any difference whatsoever. Okay? I'll be like 30 minutes, so... Yeah, that's fine. Okay, so let's do the next one here. Here's one with there's a quarter there. What kind of crap is that? Okay, so it is probably not enough room to do it there, eh? Now let's do it down the bottom here. You can figure out where to put it. 1/4 x squared minus x minus 3, and what are we going to make it equal to? 0, okay. Oh, this is ugly. This is a quarter. You got a quarter in front of that x squared. What are you going to do with it? No, don't leave it alone. Get rid of it. What did we do on the last one? What did we take out of the last one? We took out a 2. So what could we take out of this one? Could we take out a quarter? Sure, why not? Well, why not? So let's take out a quarter. Here it is. We're going to take a quarter out of this. So 1/4 divided by a quarter is, well, not 0, 1. What's anything divided by itself? 1. Okay, so it just gets rid of it, right? Don't forget there's a 1 there. Everybody always says 0, but there's actually a 1. Oh, careful now. Negative 1 divided by a quarter. Negative 1 divided by a quarter is the same as negative 1 times 4/1, which is negative 4. Oh, that actually worked out quite nice, didn't it? That's almost manageable. Negative 3 divided by 1/4. Multiply by the reciprocal. So negative 3 times negative 4, which is... negative 3 times 4, which is negative 12. Sorry, not negative times negative. Wow, that looks a little more manageable, doesn't it? Very much so. It does. And the ones you're going to get will always work that way. I'm not going to give you really ugly ones. Even with the decimals coming, I think the next one's a decimal, isn't it? Actually, the next one is a decimal. Works out really kind of cool. You'll like it. So let's factor this into 2 binomials. Again, the steps are the same. In this case, that was a GCF. Now we're going to factor it into 2 binomials. What times what gives us x squared? X and x. Hey, the negative in front of the 12 means the signs are different. 2 factors of 12, there's 1 and 12, 2 and 6, 3 and 4. Oh, there's 6 of them this time. Ooh, scary. There's 6, but which ones are they? 6 and 2, right? Because we want to subtract them to get 4. Will you get better at doing that? Oh, yeah. And we want the sign here, the 1 in front of the 4, to be negative, so where does the negative go? With the 6 or the 2? The 6, and that's a positive. Okay. And then, we've done that. How do we solve for it? Make it equal to 0. Will that quarter have any effect on this? No. X minus 6 equals a 0. X plus 2 equals 0. X equals 6. X equals negative 2. Yeah? So far? Okay. Not bad. If you had looked at these a month ago, you probably wouldn't have been able to do them. But you've seen this stuff now, right? This is all the same stuff over and over again. We're just getting more and more complex. No. Complex as we go along. Do you mean move that back up? The next one is kind of neat. Oh boy. The next one is actually really kind of interesting because you should recognize the style of this question from grade 10. So let me write it down and let's see if you get it. Now this one we can't solve just yet, right? But we can factor it, right? Normally, what's going to happen is eventually you're going to be able to solve these. Oh yeah. But right now, I'm just worried about you being able to factor that because you have to see things. This one's interesting. It's a kind of a special binomial. First off, there's no GCF on this, so when I'm just going to write it out as two brackets. You should recognize this one right away. Yeah, let me write this on the sideboard here. If I gave you that right there, x squared minus 4. You should be able to factor this right away. Now, hang on. You probably all know what the answer is. Can you take the square root of x squared? What is it? Can you take the square root of 4? Is the sign in between the 4 and the x squared negative? So what does that mean about these two signs? One's positive, one's negative. What is that called? Difference of squares. Do you remember that? We did this. What happens to the two center terms when you FOIL it out? They cancel, right, when you FOIL it out. Look at this guy here. Can you take the square root of 9x squared? 3x and 3x. Does that give you 9x squared when you multiply? Now, let's deal with the y squared. Can you take the square root of y squared? Y and y. Now, careful. The 0.64. Can you take the square root of 0.64? 0.8. What's the square root of 64? 8. What's the square root of 0.64? 0.8. Now, if you don't believe me, 0.8 times 0.8 is 64. You count the decimal places, you end up with 0.64. Basic math, right? Basic multiplication. So, you can take the square root of the 64 and the y, so 0.8y, 0.8y. Is the sign negative? So, what does this sign mean? Positive and negative. They're different. Is that a difference of squares? Yeah, it is. Who cares? It's a funny looking difference of squares, but it's still the same concept. It's still the same math. Now, normally what you would do is you'd make that equal to 0 and start solving for it. We'll get to that yet. Well, because you have two unknowns. You have an x and a y. Okay. Now, this next one. We're going to go through one of these, and I think you have to do one on the assignments. But will there be one on the test? Probably not. This is an interesting concept, this next one. You will use this in grade 12, but you don't see a lot of it in the grade 11 one. What? Well, you normally solve for x, but that's factored, right? We haven't learned that yet. Okay. Now look at this first one. Sometimes you're going to get a polynomial. A polynomial is just a bunch of different parts to it. Binomials, like they're all pieces together. But sometimes they're going to have a pattern. Now, if you look, it's m plus 2, this first one. What's normally there? When we look at the previous page, what's normally there? X squared. Okay. So that's normally an x squared. And what would this be? Negative 2x. Okay. Well, you really can't solve that with the m's. But the cool thing about math is you can substitute in different letters. If you don't like the m plus 2, you could just say, okay, wherever I see an m plus 2, I'm just going to say, I'll just use x. Well, that makes it quite a bit easier, right? Okay, so let's see. So, in this case, wherever I see an m plus 2, what am I going to substitute in? X. So x is m plus 2. Okay, so then if I rewrite the equation, instead of m plus 2 squared, it's just going to be x squared. Instead of negative 2 m plus 2, it's now just going to be negative 2x. Now look at that. Is that easy? Could you factor that? Ah. Now, when you're done factoring it, what do you have to do? Put it back in. Right? You have to put that m plus 2 back in. So you can substitute in a letter to make it really easy to solve it, and then put it back in. That's the cool thing about math. You're going to do that a lot in grade 12 with Mr. McLaughlin. All right. So then you can factor it, right? There's our factoring. Now, wherever we see an x now, what are we going to replace it? M plus 2, M plus 2. Oh, well, that's easy. So then you just combine like terms. So M plus 2 minus 3 is just M plus minus 1. M plus 2 plus 1 is just M plus 3. So that thing right there, look, that first one, this really complex sucker, when you factor it, it actually factors into that. It is actually really easy. But could you get lost in it really easy? Oh, good grief. You can get lost in this one so fast. Now there's two examples on the next page. We're only going to do one of them because we're not going to spend too much time with it. Let's do, I'll do the first one. It's a fun one. Now B is easier. A is harder. Okay. So we're going to do the first one.
In B, it's R and it's S. There are two variables. Yeah.
Yeah, well, you're not going to get that one. We'll just do A. Don't worry about it. We'll just do A. So we'll go take this one. Oh, it doesn't disappear. Okay, let's do A. So 4. Okay, so let's do this first. This is A we're going to do. Let X equals. Yes, I know. It's because I'm thinking and writing at the same time, so it doesn't often work. Let X equal what? X plus 2. So wherever we see an X plus 2, what are we going to let it equal? X, just plain old X. And then are we going to have to put it back in eventually? Yeah. Now, some people don't like that because now they're saying let X equal X plus 2. You can use a different letter if you want. Let A equals X plus 2. Let B. Right? You don't have to use the same one. Okay, so we're going to write out the equation again. Okay, so here it is. 4, instead of the X plus 2, what are we going to put? X squared plus 6 times X plus 2. Oh, that's not bad at all. I can handle that.
Oh, so the I see what happens.
We just replace the X plus 2 with X. What do we do with this thing now? Why 2? What do you think? Can't you take a 4 out of that? The GCF has to be able to come out of all the pieces. Okay, so you could take a 2 out if you wanted to. So 2x squared plus 3x plus 1. Guys, what do you think one of the most common mistakes on that last piece is? Putting 0, right? Do I see that a lot? Yeah, it's a big, big mistake. Don't do that. Well, what's 2 divided by 2? 1. So, yeah, if you were solving for it. We're not. We're just factoring. Right? What does it say at the top? It says factor each polynomial. It doesn't say solve. If you were to solve it, what do? Make the whole thing equal to 0. Okay, so let's factor this guy. I wonder if this one works. 2. You're going to factor it into 2 binomials. Now this is different because now we actually have a coefficient in front of that x squared. Big deal. What are the only 2 factors of 2x squared? 2x and x. It's the only 2 factors of 2x squared. Oh my goodness, we have a 1. Oh, what are the only 2 factors of 1?
1.
And? Oh my goodness, wow, that was tough. I don't know, does it? What does this sign mean? This positive in front of the 1. It means both signs are the same. So then we look in front of the 3 and they're both positive. So, do you think you're unsure if that's the right answer or not? That it doesn't equal 3? How do you check? FOIL. So let's do this. Now, really when we're concerned about FOIL, do we care about the F and the L? No, we're only caring about the O and the I. We're only worrying about that center one, because that's the one that's going to screw us up. So the center one is O and I. The inside and the outside. What's 2x times 1? 2x. And what's 1 times x? 1x. What's 2x and 1x? Does it work? Yes. Oh, so that one works. Are we done? Right? We can go home?
Yeah.
What do we have to do now? We have to go back and wherever we see an x, what are we going to replace it with? X plus 2. Ooh, this gets a little tricky. Okay, so let's do the first one. So the first one, wherever we see the x, we have to replace it with a what? X plus, is that what it was? X plus 2? Yeah, x plus 2. Okay, now why did I put the brackets in there like that? It's 2x, so what am I going to have to do with this 2 here? Distribute. Don't screw that one up. And what about this one? X plus 2 plus 1. Okay. So wherever I had an x there, now I'm doing it back, right? I'm going backwards now. I'm substituting back in the x plus 2. So what do I do with these ones? Do I have to distribute that? Yeah, I do. So 2, what's in here? 2x. What's 2 times 2? Plus 1? 5, so plus 5. And this side, x plus 3. Tricky though, eh? You have to be really careful. You have to really follow your rules and don't try to jump steps, right? When you get a degree in mathematics, you can jump steps all you want. Up until then, you should have to show your work.
We should make it through the B by ourselves to get it right.
Yeah, we can. You can do it afterwards. The only difference in B, if you want to try it later, no, you can try it for homework if you want. You have 3-day weekend. The only thing is for B, guys, if you're going to do B and you want to take a shot at it, I would do this. These are the two that I would do. I would use like a letter A. What did I do? 2R minus 1, and let B equal S plus 1. If you want to give that a shot this weekend, do it that way. That would be the easiest way, because you have to set up 2 variables. No, it won't take you 3 days. If you're really worried about the answer, you can go online and look at it. I have it saved there. But if not, give it a shot if you really want to. Even later today, you can give it a shot if you want. It's actually, if you can do that, you're really starting to understand math, which is a scary, scary thing.
You can blow up stuff with math.
Yes, you can blow up stuff with math. Okay, let's do 2 more examples. Oh, wow, it's going to go quick. 2 more examples. Ready? Here we go. Now, you're going to get a question like this, and this is a common way to word a question. Hey, determine the roots of that thing. The what? The x-intercepts, or what are the other names? Zeros or solutions. Is there 4 different names? Yeah, there is. You got to get used to it. Okay, so first off, if we want to make this, here it is here. If we want to make this to find the roots, what do we have to make it equal to? 0. Now the only problem is it all on one side? Yeah. All right, so we just write it out. So 2x squared minus 9x minus 5 equals 0. Can you take out a GCF? That's the first thing you should always look for. No, because nothing comes out of those. That's kind of ugly looking. Okay, so let's factor it into 2 binomials. And really, when you see these ones, don't be scared, guys, because look, you have a 2x squared. Are there only 2 factors of 2x squared?
Yeah.
And look at 5. Are there only 2 factors of 5? So it has to be some combination of that if it's going to work, right? So what's the first one? So 2x squared, what am I going to put down? 2x and x. What are the only 2 factors of 5? So 5 and 1. So you know what? I don't know. I'm going to put a 5 there and I'm going to put a 1 there. Who knows? But here's the easiest way to figure this out. The number in front of the 5 is negative. So we're going to do some subtraction in there, right? So we have to somehow get to 9. Well, what's 2 times 1? 5 times 2? 5. What's 5 subtract 2 or 2 subtract 5? 3 or negative 3. Is it 9? No. So what did I do wrong? Are they backwards? Well, let's find out. So I'll put a 1 and a 5 in here. What's 2 times 5? What's 1 times 1? What's 10 minus 1? Is that what we want? Do you see how I did that? I'm only concerned about the O and the I of the FOIL. I'm concerned about the 2 middle ones. That's it. Because the other work we're doing, we're automatically getting the answer. Yep.
Which is later taught us is last year, like we're fighting lines.
Yeah, you can do the lines if you want. Yeah, you can do that if you want. I'm just getting you to think of actually what the answers are. If I get you to actually think about it, you'll understand it a little more. Yeah, just do it this way. Okay, so the O and the I The O and the I, the outside and the inside. Okay, now, we want the number to be negative, so where does the negative have to go? With the 5, because that gives us our negative 10. We put the plus there, that gives us our plus 1. Negative 10 plus 1 is negative 9. It works. Now, if you're unsure, could you FOIL it to see if you get the right answer? Yep. But we're not done, though. It says determine the root. So do we have to solve for it? Sure, we got to solve for it. So we're going to do one, we're going to do the other. So 2x plus 1 equals 0. X minus 5 equals 0. X equals negative a half. X equals 5. Guys, you should know this one here. You move the 1 to the other side, it becomes negative, you divide by 2. If you need to put the extra step in there, go ahead. It's not going to hurt. What do you think? You like these so far? This is no fun. I love this stuff. This is math. No. No, when I was a teenager, I used to go after school and my math teacher would beat me up. Because my math teacher was my judo instructor. Yeah. No, I haven't taught it in a long time. Anyways. Yeah, I used to teach self-defense.
Yeah, I can join your class when you beat me up.
No, that's okay. Okay, so this one is an interesting one. A room is 4 meters longer than it is wide. Okay, so first off, is it a rectangle or a square? It's a rectangle. It's 4 meters long. So let me draw a little picture. Always helps if you draw pictures. I want this one. Rectangle. There it is. Okay. So the room is 4 meters longer than it is wide. So there's the width. Okay? How do I show on this diagram the length? I don't want to use the word L. W plus 4. Doesn't that make sense? Is that 4 meters wider? Yeah, it is. Now the reason I use the same letter is because when we're doing the algebra, isn't it nice when we have the same letter? Yeah, because you know how to do that, right? We've been doing that over and over again. Now, how do you find the area? Length times width. In this case, then it is W times W plus 4. Okay, so here it is here. So our formula is W times W plus 4. And what is our answer? What is it? What's our answer? That's the maximum area. Okay, so 165. You'll often see this in math where you actually have to work backwards. Like they'll want a certain amount of area for a project, and you have to figure out the dimensions. You do that in applied, you do that in pre-calc, right? Yeah, we're going to get to that. Okay, so let's distribute the W. We're going to do this, we're going to do this. Okay, so what do we get? W squared plus 4W equals equals 165. Well, can't really factor that now, can we? Why? Well, the 165 is on the other side of the equal sign. What do we want it equal to? Yeah, because don't we want the solutions, the roots, the x-intercepts? Isn't that what we're looking for? Yeah. So we can take and we can move the 165 over to this side. So W squared plus 4W minus 165 equals 0. Well, this looks familiar. This is what we've been doing all this lesson. Should we try to factor it? Now, 165 is a little bit harder because you got to think of all the different factors of 165. Yeah. But it's, okay. Hang on, let's do this. I'm going to show you something. You should remember this in a minute. Okay, so we want to factor this into two numbers equal to 0. Now, okay, so here's 165. Hang on. Let me move this down here for a sec. You can if you want. Okay, do you guys remember, hang on, you probably learned this in grade 9, the rainbow. No. Do you remember the rainbows in grade 9? Yeah. Rainbows and unicorns and fluffy bunnies. Do you remember the rainbows? No. The rainbow method is basically how you set up to look at factors. Okay, so we know two of the factors here are 1 and 165. Is that correct? Those are two of the factors. Is that correct? All right. You try 2. Does 2 go into 165? Well, does 2 go into 16? Yeah, 8 times, but does 2 go into 5? Not evenly. So 2 doesn't work. What about 3? 3 goes into 16 4 times, right? That would be 12, then 45. Does 3 go into 45? Does 3 go into 45? How many times? So what's our factors on those ones?
30.
3 and... We'll go the other way. Take 165 and divide it by 3. What do you get? That's why you have your calculator in front of you. 165 divided by 3. So 3 and 55. Is that correct? 3 and 45, 3 and 55, is that right? Okay. There's another part of our rainbow. What about 4? Does 4 go in?
No.
Does 5 go in? 5 better go in because it ends in a 5. 33? What's 5? What is it? You see the rainbow starting to form here?
Oh, and then the 1, 3, 5 are all clouds.
No. Does 4 work? Sorry, does 6 work? 7, 8, 9, 11 and 15. Now, if you notice, are these numbers getting closer together every time? 1 and 165, 3 and 55, 5 and 33, 11 and 15. Are they getting closer together? So the only possible ones left could be 12, 13, or 14, which obviously doesn't work. Okay. Those are all the factors. Now, another way to do that is to do prime factorization. Do you remember that?
No.
We'll talk about that later. Now, the nice thing about doing the rainbow method is, and listen here, guys, when you're actually looking for an answer to a question like this, probably about 90% of the time, the answer you're looking for is the middle ones. So what's the two middle ones? And 11 and 15. If you subtract 11 and 15, what number do you get? 4. About 90% of the time, the ones you're going to be looking for are the middle ones. They're not going to be the 5 and the 33. Now, that doesn't say that they couldn't be, right? But normally the ones you're looking for are the middle ones. Okay, so we want in here, what numbers do we want? 11 and 15, right? These are both W's. Okay, now, the number in front of 165 is negative, which means our signs are different. We want it to be positive 4, so where does the plus go? In front of the 15 or the 11? It's 15. Okay. Good. How do we solve for this now? You make them equal to 0. You make the left side equal to 0. You make the right side equal to 0. So W minus 11 equals 0. W plus 15 equals 0. W equals 11. W equals negative 15. Is that correct? Like, I mean, the question changed, but we still solve it exactly the same way. Does anybody have an issue with this? No issue whatsoever. Sorry, what? This is factoring. Hang on, guys, you're missing the point here. Stop. Back up the bus. Right? We got 2 answers, right? Mathematically, we got 2 answers. Mathematically, we got 2 answers. But think about this for a minute. What's the width of the first one? The left side. What's the width of that left side one? 11. What's the width of the other one? It is not possible. Can you have negative length? Yeah. Like, how far is it from me to you?
5 steps.
5 steps. So you say negative 5 steps?
No.
Guys, how far is it from here to Winnipeg?
Negative.
Negative 200 kilometers?
Yeah.
You don't say that.
Yeah.
You say 200, it's always positive. So, what's with the deal of this negative 15? Can it exist? No, it has a special name. It's called an extraneous root. An extraneous root, like we need to have that negative 15 because we need it there to solve mathematically, right? We need that negative 15 so we can do the math. But is it an actual answer? No. It's extraneous. It does not exist. You can't have negative length, or negative width in this case, sorry. So it's just an extra piece of information. Now what's going to happen is, as we go through these questions more and more, you're always going to have to test, at the end when you're finally done, you're always going to have to test for extraneous roots. You plug it back in. If it doesn't work, if it's negative, for instance, if it's anything to do with distance and it's negative. But our answer, we're still not done. So our width is 11. What does our length have to be in this case? It's 11, it's W plus 4, right? Which is 11 plus 4, which is 15 meters. Now in this case, it's interesting that it's 15, and we got negative 15 as one of our answers. Sometimes it works out that way. Right? But the negative 15 is an extraneous root. Get used to seeing that term because I will use it a lot. Okay. This kind of makes sense, this stuff. It's still the same basic concepts where you take a trinomial or some variation of a trinomial and try to factor it. This is the hard part. And every time you do this, when you factor this and you're finding roots, you're actually always finding x-intercepts. Because eventually we're going to start putting the combinations together where you graph them and do all this. Okay? So far so good? All right, you can start on today's assignment. You have today and Monday. Where's the work class to work on it?